everybody, welcome to the third session of Deep Learning tutorial. In this session, I want to tell you about cost function. But before that, I want to remind you some points about previous session. As I told you, you have to know what category this problem belongs to understand how to behave with the model. What I mean is that you want a model to do some specific tasks, so you have to choose a category. For example, you want the system to tell you what this picture is. This is a picture of a cat, a dog, a cow, something like that. Or you want the system to predict how much money you have to pay to buy a house, based on how many bedrooms it has or how big it is. Image classification is a discrete problem. What I mean is that this picture is either a cat or a dog. It cannot be a combination of cat and dog. It belongs to just one category. A. Dogs, B. Cats. But about buying a house, things are different. System can predict any number. For example, you have to pay $4,000 or $5,000 or something between them. So that's a continuous number. You can have classification problem or regression problem in supervised, unsupervised, or semi-supervised learning. It depends on your data. If you have a data set which is all labeled, then you have supervised learning. If your data set doesn't have any label, then it is unsupervised. And if it is a combination of labeled and unlabeled data, for example, 10% of the data set is labeled and 90% of that doesn't have any label, then it is semi-supervised learning. This was a review from previous session. Most of the answers you sent me were correct, but I thought it would be better to review one more time for people who answered me wrong. So what is cost function? Cost function quantifies the error between the actual value and the predicted value. Depends on what problem is, it can be formed in many ways. Let's talk about a regression problem. As you remember, in regression problem, we have some lines that pass through the data. The goal is to find the line that can cover most of the data. The more it can cover the data, the less the cost function is. So here we have three lines, A, B, and C. We can see that B is better than A because it can cover more data than A. But C is better than B because it can cover most of the data. So if you calculate the cost function of three lines, you can understand that the cost function of C is the least one. So the goal is to find the least cost function. As you can see, cost function of C is the least in these three lines. But what if we want to find the best line exists, not just between three lines, between too many lines? Let's review about linear graph. As you remember, this is a linear graph formula, and A is the slope of the line and B is y-intercepts. Now let's look at these two formulas. As you can see, they are the same, but the difference is A and B. Here A is 1 and here A is 3. Here B is 2 and here B is 1. And as you can see, you have two lines. This belongs to red one and this belongs to blue one. Therefore, you can create some lines by changing A's and B's. So you can create too many lines. There's no limit. So how can we find the best line with the least cost function? In machine learning, we don't use Y, A, or B. We use this. It's just like that, and the difference is that just we use h instead of y, and we use theta instead of a and b. And we call this function hypothesis. Finally, we can find this. As you can see, we show cost function with j, and this m shows the number of examples. H is what the system predicts, and y is the real output. I will talk fully about this formula next session, so don't worry about it. Now, I think it's enough for this session. Don't worry if you don't understand some parts or you have too many questions in your mind. You will find all the answers of your questions by the time. If you enjoyed this video, please like us. And if you didn't subscribe yet, please subscribe our channel. And turn on all the notifications so every time I publish a video, you will be notified.